Hey there, sixth graders. I hope you're doing great. We're going to talk a little bit of review for math. Before, we had talked about exponential power and exponents and the parts of them, and we have the base and the power. And we are going to use that information to help us break down some big numbers into smaller parts. So basically, we're just decomposing numbers. So again, exponents, the base, the power, we want to work on that and make it something that kind of makes sense to you. So let's take a look at these numbers. 45 and 200. If we can break down 45 into smaller parts, you might ask yourself, what times what gives me 45? You could say 15 and 3. You could say 1 and 45, but that isn't going to help you much. 9 and 5 is typically what kids will say. So let's go with 9 times 5. As you do that, you can ask yourself, well, is either one of these numbers, are either one of these numbers prime? Well, we know 5 is, because 5 only has the factors of 1 and 5. But 9 can be broken down further. 9 can be broken down into 3 and 3. So when we do what's called prime factorization, our prime factorization looks like 3 times 3 times 5. How many 3's do you see? You see 2 of them. So 2 is our exponent. And it's going to look like that once you've broken that down further into exponential notation. Now the question is, do 45 and 200 have a factor in common that's big? Prime factorization, greatest common factor. Let's take 200, and a lot of people will say, hey, I can break that down into 20 and 10. Okay, that's good. Remember, it's still 20 times 10. We haven't lost the value here. 10 breaks down into 5 times 2. 5 times 2. 20 can break down into 10 times 2. Look at, we have 2 2's here. See that? 5 is already prime, 2 is already prime, 2 is already prime. We're almost done. 10 breaks down into 5 times 2. And then we pull the 2 down, pull the 5 down, pull the 2 down. Don't forget your multiplication parts. How many 5's do you see? Yeah, we see 5 to the power of 2. How many 2's do you see? Yep, we have 2 to the power of 3. And so what do they have in common? Well, they definitely have a 5. They have one of the 5's. Is that it? There are no 3's in both lists. We don't have 2's in both lists, and we don't have any more 5's. So our GCF for these large numbers, the greatest common factor is just 5. That's it. It's just 5. Okay. If we were to find least common multiples, which is a totally different subject, we would skip count by 45's. We would skip count by 200's until we came to a multiple that was in both lists. So you're going to have to know GCF, greatest common factor, that, and LCM, which is least common multiple, which is the skip counting part. I hope that helps and makes a little bit of sense. It can be confusing, I get it. We'll keep working at it. Have a great day.